In this video, I'm going to explain how to use long division and synthetic division to divide polynomials. First, let's remember how we do long division with whole numbers. First, we have to set up the long division. And if we think of this division problem as being a fraction, 296 over 8, then on the outside goes the denominator, and on the inside goes the numerator. Now, thinking about this 8, we ask ourselves, how many times does that 8 go into 2? And well, it doesn't go in there evenly at all. Then we ask ourselves, how many times does this 8 go into 29? And the answer to that is 3 times. So we take 3 times 8 is 24 and subtract. That'll leave us with 5. So bring down the 6 and repeat the same process. Look at that 8. How many times does 8 go into 56? And that would be 7 times, and 7 times 8 is 56. So when we subtract, we're left with 0. So what that means is that we could rewrite 296 as 8 times 37. So this division problem means 8 times 37 would equal 296. So let's try it again with some more numbers. This time, take 301 divided by 11. Thinking about that as a fraction, that would be 301 over 11. So the denominator is on the outside and the numerator is on the inside. Now, ask yourself, how many times does 11 go into 30? And that would be twice. 2 times 11 is 22. And when we subtract, we're left with 8. Bring down the 1 and go through the process again. How many times does 8 go into 81? Well, that would be 7 times, and 7 times 11 is 77. When we subtract, we're left with 4. There's nothing else to bring down. So how we'll deal with that is to write this extra 4 as remainder of 4. What that's going to mean to us is that we can rewrite this division as a product. 301 is 11 times 27 with the remainder of 4. So we'll add that 4. Here are 2 more problems for you to try on your own. Write them down on a separate piece of paper and press pause. These are the solutions to these 2 problems. So pause the video and review your work compared to this. So let's try the same process with polynomials. Think of that quadratic as being the numerator of a fraction, and then the x plus 4 as being the denominator of our fraction. Then when we set up the long division, the denominator is on the outside, x plus 4, and on the inside we'll have the quadratic, the numerator, x squared minus 3x minus 28. And just like before, how we were going to ask how many times does this number go into that number, now we're going to ask ourselves how many times does this x go into x squared, or what do I have to multiply this x by to turn it into x squared? And I need to multiply x by x. Then do that multiplication. But do the multiplication on the entire binomial, the x plus 4. So x times x plus 4 is x squared plus 4x. Then subtract. Now be careful and subtract the whole thing. I like to use parentheses to remind myself of that. Then when we do that subtraction, x squared minus x squared is nothing, and negative 3x minus 4x is negative 7x. Bring down the negative 28, the minus 28, and repeat the process. So how many times does x go into negative 7x? Or what do I have to multiply x by to turn it into negative 7x? And that would be negative 7. Negative 7 times x plus 4 is negative 7x minus 28. When we do that subtraction, remember to subtract the entire expression. Then negative 7x minus negative 7x is 0. And negative 28 minus negative 28 is also 0. So that means we have a remainder of 0. So how could we rewrite this as a multiplication problem? What this is going to mean, just like before, is that x squared minus 3x minus 28 could be rewritten as the product of this and this. So that's equal to x plus 4 times x minus 7. Let's do it one more time. Again, thinking about this division problem as a fraction, x squared plus 5x minus 1 divided by x plus 3. So the denominator stays on the outside, x plus 3. And on the inside, we'll have x squared plus 5x minus 1. Now, what do we have to multiply x by to turn it into x squared? And that would be x. Remember to multiply that x by the entire binomial, and we'll have x squared plus 3x. Then subtract the whole thing. X squared minus x squared is nothing. 5x minus 3x is 2x. Bring down the next term, the minus 1, and repeat the process. What do we multiply x by to turn it into 2x? And that would be 2. 2 times x plus 3 is 2x plus 6. Then subtract the whole thing. 2x minus 2x is nothing, but negative 1 minus 6 is negative 7. So we have a remainder of negative 7. What that means for us is that we could rewrite x squared plus 5x minus 1 as that product, x plus 3 times x plus 2 plus the remainder. So plus a negative 7 is the same thing as subtracting 7. Here are 2 more problems for you to try on your own. Write them down and hit pause. And these are the solutions. Check your answers to see how you did. We have another process for dividing polynomials called synthetic division. This method is very nice because it takes up a lot less space on your paper. How it works is when we have one polynomial divided by another linear binomial, that's important. This divisor has to be a linear polynomial, x plus or minus something. Now, to set it up, we first look at what would normally be in our numerator, the x squared minus 8x minus 65. And what I'm going to do is take all the coefficients of each term and write them down. So 1x squared minus 8x minus 65. To the left of those coefficients, I'm going to put this little box. Inside the box goes the 0 of this factor, the x plus 5. Inside of the box, I'm going to put negative 5. That's the number that makes this thing equal to 0. To finish setting it up, I'm going to leave a space underneath my coefficients, draw a long horizontal line, and leave a little dividing mark between my last and next to last coefficients. Now, to perform synthetic division, the first thing I'll do is bring down the 1. Then I tell myself, multiply and add, multiply and add, multiply and add. I'm going to take this 1 and multiply it by the negative 5. That will give me negative 5. That's my multiply. Now, add negative 13. Once again, multiply and add. So when I multiply that negative 13 by the negative 5, we get positive 65, and then add 0. So multiply and add, multiply and add, multiply and add. When we're all finished, there's 3 parts to look at. We still have this negative 5 right here. That's going to be important. The 1 and negative 13 is important, and so is the 0. What all of this means is that we can rewrite our polynomial x squared minus 8x minus 65 as a product. The first product is from this negative 5. That was the x plus 5. Next, the 1 minus 13. That'll give us our next factor, x minus 13. Finally, we have the 0. That's our remainder. since we have a remainder of 0, x squared minus 8x minus 65 can be rewritten as x plus 5 times x minus 13. So let's try to set it up. Write out the coefficients of that quadratic, which are going to be 1x squared plus 3x plus 11. In the box to the left, we're going to put the thing that makes x minus 6 equal to 0. That'd be positive 6. Draw our long line and leave a mark. Now, perform synthetic division. Bring down the 1. Multiply and add, multiply and add, multiply and add. So I'm going to take that 1 and multiply it by 6. Then add. Now, take the 9, multiply it by 6. Then add. 11 plus 54 is 65. Now we have the 3 parts that will make up our products. The 6, the 1 and 9, and the remainder of 65. So, x squared plus 3x plus 11 can be rewritten as, from the 6, that would be x minus 6. From the 1 and 9, that's going to be x plus 9. And our remainder is 65, so we say plus 65. This type of division is really great when we have very large polynomials that we want to divide. So when we look at this big one, x to the 5th plus 4x to the 4th minus 2x squared plus x minus 7. First thing we do is write down all of our coefficients. We have a 1x to the 5th, 4x to the 4th, and you might notice that there's no x to the 3rd term. So we have to put a 0 there for that. Then there are negative 2x squareds plus 1x minus 7. In the box to the left, we're dividing by x plus 2, so I'm going to use negative 2. Draw my long line and my mark between the last and next to last coefficients. Now we're ready to perform synthetic division. So, bring down the 1, multiply and add, multiply and add, multiply and add. 1 times the negative 2 is going to give me negative 2. And then add. 4 plus negative 2 is 2. Multiply. Then make negative 4. Then add. 0 minus 4 is negative 4. Multiply. That makes 8. Negative 2 plus 8 is 6. Multiply. And add. Multiply. And add. Now we have our solution. What that means is that we can take x to the 5th plus 4x to the 4th minus 2x squared plus x minus 7. That can be rewritten as, from our negative 2, that's x plus 2. From this big long string of numbers, that's going to be 1x to the 4th plus 2x to the 3rd minus 4x squared plus 6x minus 11. Now you might be wondering, how did I know to start with x to the 4th? And there's a couple of ways to tell. First of all, I'm taking an x to the 5th and dividing it by x. That means that this second factor here is always going to have a degree that's 1 less than what we started with. Since I started with x to the 5th, this one should start with x to the 4th. The other thing you can think about is that this thing's going to turn into our polynomial, where negative 11 is our constant term, and then we could just work our way up. So the 6 has to be for 6x, the negative 4 has to be for negative 4x squared, the 2 has to be for 2x to the 3rd, and that 1 then would be for 1x to the 4th. Anyway, finish it up with our 15. That's our remainder. So we'll add 15. Then we're done. Here are 2 more for you to try on your own. Write them down on a separate sheet of paper and pause the video. These are the solutions to these 2 problems. Check your work and see if you did them right.